Hello friends, good morning, good afternoon, good evening from whichever part of the world you're watching the video. And let's continue our configuration of the SuSE clusters. This is our third video in continuation to the SuSE Iscsi configuration series. And in this video we are going to do the configuration of our Scuzzy targets. We'll be defining our Scuzzy target here, and we'll be connecting the storage, the shared storage access on all our servers, so that when we go on with the configuration of our highly available file system using OCFS2 and GFS2, we are having a shared access and it can be used with the concurrent accessibility across the cluster nodes. Okay, so let's begin our configuration. Here we have the same infrastructure which we have used in our last video. So here I have my first machine, which is my SAN target, second machine which is my cluster node 1, and my third node which is my cluster node 2. Okay, and as in our last video we have done the configuration of our passwordless authentication, so we'll continue with the same from the same point onwards. So here on my machine, just for the validation, let's check it. SSH cluster node 1, I can do it, and SSH cluster node 2, I can do it. So we are capable of doing our cluster node configuration with the open source, and we can do it a passwordless authentication here. So on this machine now we are going to configure it as a Ntp server. We all know that the network time protocol servers are used for the configuration of our time protocols and time synchronization. So in this video again we are going to do the same. We will be configuring our server for time synchronization from the global servers and then to our local servers. Okay, so for this purpose I'll tell you what is the best method to select in your most nearby time servers. Just open your favorite web browser and visit the website ntp.org, and then from ntp.org website go to the section Ntp public servers, and in your Ntp public server listing look for the zone of the world where you are, because when you do a synchronization from the most nearby Ntp server it becomes easy, and the time synchronization takes less hops there. So I'll be selecting in the public Ntp time servers there. Now you have an option, you can select in the particular time zone, the part of the globe, like you are into Asia, Europe, North America, South America, Oceania. Accordingly make in your particular pool servers. Like presently I'm recording this video from the Asian region, so I'm selecting in the Asia pool ntp.org. And here these are the 4 server listing that we are going to use for our Asian pool. If you want to deep dive to reduce the time required in synchronization, the first synchronization, and have less drifting, then in that case you can have the specific country based servers which you can visualize in here. Like you have the servers for United Arab Emirates, China, Cyprus, Georgia, Hong Kong, India, and Korea, Kuwait, Kazakhstan. Multiple servers are available, and all these are into the Asian region. So if you want, you can go deep to that particular country from where you are recording and select in the respective server. Or so here these are my Asian pool servers, and this particular server which I'm going to check in will be the specific to my UAE. Okay, so here a.pool.ntp.org, that we can use it, but I'll be just using in the servers which are specific to our these 4 server 0, 1, 2, 3 with my 0.asia pool ntp. So similar is the configuration what we are doing in here, and here on my machine I just said vi etc ntp.org. If in case you face a challenge in opening this file, then firstly validate rpm-qa pipe grep-i ntp, and validate that you have the ntp 4.2 and YAST ntp client package there. Okay, So I have installed all these packages on my 3 machines, and if you do a graphical installation, the packages are by default available to you. Okay, so here I'll just go to vi etc ntp.conf file, and in this file just go to the top, and here I've added the same entries. Just ensure that you add the iBus to it so that the time synchronization is into burst updates there. Okay, and I have added all those servers. Another entry that you'll have to do is come down, and on your line where it says clients from this example subnet, so in my case my subnet is 192.168.200.0, just mention in your subnet address and the subnet mask set. This is I'm allowing this line we are using so that I can tell that what all local network devices are allowed, or what particular network subnets are allowed to synchronize time from this particular server. Okay, so once you do it, after that execute the command systemctl enable ntpd, so that after my server reboots and the maintenance activities, my NTP server comes automatically, and then run your command systemctl restart ntpd.service. Okay, and then go to your client node, or in spite of switching in, because we have already done in the synchronization of our servers. So first step, run the command systemctl enable ntpd, and then run the command systemctl restart ntpd. Okay, now we'll do what? We'll check ntpq-p to validate if in case we have got the time synchronization from a server. Okay, so this little asterisk mark, this shows me that which particular server is the one I'm synchronized to right now. Okay, so this is small asterisk mark. If you visualize, this shows that my server is presently synchronized with this NTP. Okay, and let's do SSH to our cluster node 1. Sorry, my mistake. SSH cluster node 1. Here also we'll do the same job. vi etc ntp.conf file, and we'll just do, here we'll add only one line, and that line is mentioning the server with IP address of my local server, the local NTP server that we have configured. Give its address there. Okay, and then here also systemctl enable ntpd that service, and systemctl restart ntpd service. We'll do the same on our third server also, cnode 2 system. Okay, just let me do the configuration. etc ntp.conf, and again do the same, add the entry server with your local address. Okay, and then we'll do systemctl restart ntpd and systemctl enable ntpd. Okay, you can validate if in case it's there or not by running the command systemctl is enabled ntpd. So if it comes, that means the ntpd service is done. Okay, so now we have our ntp service configured, and to validate, let's go to our cluster node 1 and run the command ntpq-p. Yes, it is initialized, and you can also do time date ctl set-ntp on, and validate if in case the server has synchronized with your NTP service or not by running the command time date ctl. Yes, we can visualize that my system is now configured with the proper time here. Okay, the same way we'll do the process for our third server also, cnode 2, and time date ctl set-ntp on, and time date ctl validate. Yes, here also time is synchronized. Okay, so now all the three machines are in synchronization. So this is my first server where I'm going to configure my target, Scuzzy target. We are going to make this machine as our publisher for the Scuzzy services. We'll be sending our sandblock devices from here. So for this purpose, first step, I need to check if I have the Scuzzy LIO server package or not. Scuzzy LIO, sorry. So if in case you don't have this Scuzzy LIO package, you need to get the package installed from your zipper repository. Okay, so we'll do here something different. You have a, like in Red Hat you have the yum tool. Here we have a tool by the name zipper. So zipper lr, that is list my repositories. So this shows me I have a SuSE 12 service pack 3 repository which is enabled. Okay, and we'll do zipper search ISCSI LIO. So this shows me that there is a package available by the name YAS2 Scuzzy LIO server, but the package is not installed. Okay, if in case you get a value I here in this section, that means the package is installed. So we'll simply do zipper install -y Scuzzy LIO server. So this installed the package on my box. Okay, and then let us check it back again by running our Scuzzy command. Okay, package is here. Let us also check if I have the Scuzzy Initiator package. So rpm -qa once again, pipe grep ISCSI query all, and the Scuzzy client package is already available on my system. Okay, so but before we make it as a SAN publisher, let us add 2 more hard disks to it, which we can use it for publishing the systems there. Okay, presently if you check on my box, lsplk command, and this shows me that I have only one hard disk, and that disk is by the name SDA, and the whole space of this SDA disk is utilized, so I cannot use it for any other thing. Okay, so what I'll be doing is I'll be just adding in 2 new hard disks to the system. Click on add, next, Scuzzy create new virtual hard disk. I'll store it as a single. I'm adding it a 20 gig file, and I'll add one more, next, and this one I'll be using up as again say 10 gigs, and one more disk of capacity. I'm going to use it as 2 gigs. Okay, so now we have added 3 disks. Here some things we might have to do lsplk, and if I check path probe, and after doing my path probing also I can have a partition outside disk. Okay, lsplk, let's see. No, it doesn't showing me the other 2 devices, so till the time I don't get the other device, I'll not be able to access it. One easy method is I'm just creating in a small script, or I'm just running in a command. Yeah, let me do it. vi scan disk, and here bash exclamation ben bash to use my bash shell, and for say counter in backtick sequence 0 to 32. Yeah, 32 only. Okay, do echo dash dash dash. I hope you are aware why we are doing it. Sys class Scuzzy underscore host slash host dollar counter slash scan, and done. This script will simply do what will allow me to scan my disk. It's forcing my kernel to do a scanning of all my SCSI class devices there, and then discover if in case any new disk is available. Let's see if it works. LSB yes, our script worked, and here now we are having 3 new devices added onto it. Okay, so now we have the 3 new disks, and this time we'll be executing in our yes command to simply create it. That's the most easiest way to work on your SuSE environment. Okay, so I'll execute the command yes2, and we will come down to your Scuzzy LIO target. Now if you check in, till the time you have not installed the package, you don't have the Scuzzy LIO target. So we'll click on it. So when I want my service to start, I say whenever my system reboots, so after every reboot my service should be started. Then global parameters, I do not want any authentication protocol, but in real-time production when you talk about the SAN deployments and all, so your storage admins would have already done it, and there you will be using in the authentication from your ISNS servers and all. So here we are just keeping it up as no discovery authentication, and then which targets are available to me. My first target, I'm going to give it a name as com.ats, and my identifier, I'll not use in something, I'll simply say it as target 1. My IP address is this to be used, and don't use login authentication. Okay, bind all IP address target 1. Next. Now if in case you want that this target be available to a particular node in your cluster scenario, then in that case you can do a iSCSI initiator mapping. It's like creating in your LUN masking on the storage environments. So here I'll just simply do SSH to my cluster node 1, and we'll check for the initiator ID. This you can find in the file SuSE Iscsi initiator name.iscsi. Okay, and here my IQN is mentioned on here like this, SuSE. So if you want, you can customize it to the respective nodes. I'm just taking in the same what it is as it is so that I can do the configuration. Okay, because we just require it for doing the key. So I'll do add map from the target portal group to here. In the same way, we'll go in SSH to our cluster node 2 and check the same configuration file, Scuzzy name initiator. Okay, and then here we got in our IQN, which is quite same, so we'll have to do some changes. Let's see. Okay, let's just add it using here, and let us change it to iqn.2.18-10.com.ats cluster node. We are on cluster node 2. Okay. Yeah, now our IQN is updated. We'll just copy it and add it another initiator binding to it. Why we are doing this process is because we want that this target be accessible only by these 2 cluster nodes, and no other node should be able to access it. Okay, so exit. Okay, let's do one thing. Let's change the IQN off over this node also. Equals to cluster node 1. Okay, and that's good. So we'll just make modifications here, some slight changes that we did earlier. Scuzzy target, just the target modification, and we'll go back. Yeah, we'll edit it. I'm removing the first one and adding. Okay. Oops, sorry. So first one is my node 2, and second one is my node 1. Okay. Now let us try to check it by running the command validating rpm-qa grep-i Scuzzy. So here we have the Scuzzy client utility. Simply run Scuzzy adm -m discovery -t send targets and -p the IP of my sandbox. Okay, we got it. So we'll just do a copy of it, and then again adm -m node -P and paste it as it is, followed by -l. Login successful. And here if you check lsblk, okay, not successful. Okay, and okay, the same process, repeat it on your second node, SSH2. So I'm pausing the video for the whole completion process. Okay, so here if we check, once we did the Scuzzy login and we got connected, so here lsblk now shows me that I have one hard disk and another hard disk of 20 gigs capacity added to it. Okay, a similar thing we can check it on our cluster node 1 and lsblk. So here I have only one. I'll just do Scuzzy adm -m node -P 192.168.200.1 logout, and then log back in. Okay, so once we got both the devices connected, now what we'll do is we'll go to one of the cluster node and install the packages for our cluster configuration. Okay, so here you can visualize how we did it. Allow target, okay, and once it is up, when booting, global parameters, no authentication, targets. I have one target. You can add in one more target. Okay, and used login authentication, no. Find all IP addresses and add a new logical device here as dev/sdc, name tgt2, add another device dev/std tgt3. okay, then we go next and we do the same initiator mapping, cluster node 2 bound to 0 0, cluster node 1 again the same bindings, next, finish. And once it's done, now if I go back to my cluster node 2, do lsblk, see you got a device here, here also you got a device, as of now none. So what we'll do is we will again log out from the portal from both the nodes, -hyphen log out. Okay, we'll do the discovery once again, Scuzzy ADM -m discovery. So now this time you check, one target was we have given the name and the other two targets we have not given the name. Okay, and we check in here the same, do the discovery once more. You got it, two targets coming in here, two targets coming in here. It's here, it's here, and we'll just do the login. Okay, and here also we'll do the, okay, we are getting another IP address also. Let's just do one small change here in our target. I know this video got a little bit lengthy, kindly bear with me. Okay, go to your targets, yep, one step back, let it, okay, use only one, and this one again we'll use not the bind all IP addresses. Okay, okay, finish, so that it doesn't gives me both the addresses to be bound out, log out, and log in. It's giving me a related to my 1.126, which is my global interface, and I don't have that address. Node and login, successful. I'll just close it. And if you check lsblk, now here you have two devices B and C added. The same way on our second disk also we have lsblk B and C, two more disk added. Okay, so in this video that's all. In our next video we'll start with the cluster deployment. Thank you all for watching, thank you for joining in, and I hope the video has been informative for you.